I finally found a way because I was so bored with myself that every time I have to do the same thing. So my friends here, Amr, decided to do this presentation for me, and I really thank him for helping me with this presentation. So I would like to take this opportunity, first of all, to welcome you to the Sharjah Research and Technology Park, and thank you for making the time and being with us here. I know some of you drove from Dubai, and I know how difficult is this, but I hope your visit is worthwhile. I hope you will find this session of a benefit to you. I hope you will walk away with a new networking, with meeting new people, and maybe hopefully new business opportunity. Today's session is a very exciting session for us because first of all, we are hosting leading experts in additive manufacturing and the future of manufacturing in this region. These leading experts come from academia and from businesses. But also this also goes hand in hand with the UAE recent strategy for advanced manufacturing. As you know, UAE just launched recently an advanced manufacturing strategy, and I welcome our colleagues from the ministry here. And this is something is very, very important for the UAE economy. Today we are talking about $150 billion amount of industries. The UAE, and I think by 2030, aiming to hit 300 billion. And those 150 will come from technologies that we are going to talk about today. So without taking more time, I really thank you for being with us here. I really appreciate that you took the time and you are attending this event, and I hope you will enjoy this event and enjoy the speakers as well. Before we invite the speakers, I think there is 1 or 2 minutes videos about the additive manufacturing and about the UAE industrial strategy. So I think we can put the videos, and then I will ask Ismail and Fahmi and Pierre and Dr. Adil to also join us here to start the session. Thank you very much.
All right, I would like to invite the speakers. Thank you very much. First of all, I would like to thank you for coming tonight for this interesting evening, where we are basically going to discuss the impact of advanced manufacturing and industry 4.0 on the basically the small and large manufacturing companies, as well as education and production in general. First of all, my name is Ismail Tog. I'm the director of Sharjah Open Innovation Lab. I'm sure most of you have visited the lab already and got an idea. Soy Lab, basically, it's an open prototyping lab, which basically means anyone from any organization or even individuals can join, can learn how to use the equipments and the technologies we have, and they can start developing their own products. And second of all, I would like to introduce our guests here, starting with Dr. Adil. Please tell us your background and your specialty, please.
Thank you.
Yeah.
Shall I use this? Good evening, and thank you, Chairman. My name is Professor Adil Al-Tamimi from the American University of Sharjah. I am blessed to know the research park from its inception, when it was nuclear, small, when it started back in 2017, when I got to know His Excellency Al-Mahmoudi. He was a CEO at our university. And all it comes like small idea from the beginning. It was idea from himself, and background, technology, and theory from myself together. And the first idea he came out with is about the 3D concrete printing. And it comes like a dream come true for me, myself, because I was teaching 3D concrete printing at the American University of Sharjah for the last 15 years in theory. We didn't have the time and effort to vision or to start practical 3D concrete printing. Although myself, I was engaged with many other technologies. For example, nanotechnology, self-cleaning concrete, high strength. Recently, I was working with COVID kind of protection for buildings, but 3D concrete, it was on the table, but this bark lift this idea from the table to practice. Now, as we speak, I have, for example, 5 master students and PhD students. All of them are working on 3D. And this is all because of this small idea, which it comes true, and we try to make it even larger and larger with time. I don't want to take much of your time. This is just myself, humbly, Professor Adil Tamimi, with experience of around maybe, well, don't look at my face, but it is 35 years in the construction and concrete technology. Thank you very much.
Thank you. Fahmi Shawa, I'm the CEO of Immensa Technology Labs. We're a regional additive manufacturing company focusing on industrial 3D printing. I'm proud to say that we've been working with Sharjah Research Technology Innovation Park for almost 3 years now. And I want to say hats off to the team for what they've built. They're the first non-academic additive manufacturing facility for metal, which has been very progressive. They have the largest footprint, and it's been really a pleasure working with them. I'm proud to be here. Thank you.
My name is Pete Arkham, and I'm the founder and CEO of Proto 21 3D Printing LLC. It's a startup. We started like 3 years ago, and it has been overwhelming experience in this region. We are focused in industrial 3D printing alongside with some show-off models, props, and other different industries such as defense, medical, retail, and lots of other factors. We also used to provide 3D printing training courses, and we used to educate the market, and we go from clients to businesses as ADNOC, Adidas, Minister of Defense, and many others. The recent biggest model that we have done is in Dubai Mall. It's a 32-meter long 3D printed item that is installed in Adidas store. And I'm really glad to be here, and I wanted to be a part of SRTIP and have another a geographical location in UAE through this great infrastructure we have. It's a pleasure to be with all of you. Thank you.
Thank you very much. It's a great opportunity that we have 2 of the leading companies in 3D printing, and as well as Dr. Adil here from academia to give us a broad perspective of how 3D printing, digitization, and Industry 4.0 is changing the future of manufacturing in general. The first question I wanted to ask you is, what is your definition of Industry 4.0 and advanced manufacturing, or let's call it smart manufacturing? Who would like to begin with?
So my humble understanding of Industry 4.0, it encompasses a lot of things, but I think it's the transformation of going from very manual, human-based manufacturing into more digital, more automated process. So whether it's robotic, whether it's additive manufacturing, whether we're utilizing artificial intelligence of additive manufacturing, it's all this transformation where we've been through different industrial revolutions. So it's really sort of the complete change of how things are manufactured.
I mean, from your perspective, I'm sure you have a great visibility over how 3D printing is serving different industries in the region, whether it's oil and gas, education, sport companies like Adidas. 3D printing is something that everybody looks at and they find it amazing, but not a lot of people can see the possibilities of what they can use 3D printing for. So from your perspective and from dealing with all these clients, how do you see this transition in way of thinking by introducing new technology, especially 3D printing and digitization? Would you like to answer?
The best way to understand that would be to start from a case. If I can say, just recently we did some, there's a concept of digital inventory. And the idea is about to digitize the process and to get faster in the progress towards Industry 4.0. We need to reduce the stocks that companies have for the spare parts. Imensa is doing very well in this particular field ahead. But recently we got a chance to work with DHL, for instance. So they had this in their supply chain logistic, they have the rollers, which just moves the boxes to the certain location and designations in their full chain. In those rollers, for example, they were short of some supplies, and they created a digital file for it with us. And whenever they require any item that is like weared off with the process, they can order bespoke. So that means, and alongside, if you think of having any product developed, let's say, let's talk about a normal device. Let's say we did a hair removal device for a doctor. So when it comes to, he was using that, he's an old man and he used to use the hair removal device and hold it every day for, let's say, more than 6 hours. So we designed we scanned the hand and we designed the hair removal device specifically made for his personal use. So these kind of things, otherwise, if there's no 3D printing, would be very difficult to achieve. So 3D printing helps in the digital part of it faster. And I think that is very useful for companies to get into the digital world and reduce the stocks in their warehouses to make most use of it.
We can switch a little bit now to the educational sector. We're noticing that the job requirements now in the new industries is developing very rapidly. From your point of view, do you think the educational sector is catching up with the requirements of basically the companies of what they are expecting from the students, or do you think there is a lag in that regard?
Thank you. This is a great question. Yes, education is not easy to change rapidly, as you know, but we have to go with the market as well. For example, nowadays we are having courses on intelligence, artificial intelligence for our students. And in the lab, in fact, our lab, it is like the kitchen in our house. A lot of people, they like to go to the kitchen for food, but for ourselves, we like to go to the lab to innovate. Now, education, it is moving to more sustainable. We inject a lot of principles of sustainability in our courses nowadays. It has already implemented. Our students now understand what's the meaning of sustainable construction and how they apply it. One of them is the 3D, the additive manufacturing. So we are trying to run along with the advancement. And so sometimes we go beyond the advancement. The 3D concrete printing, when we started, it was just idea in the whole UAE, but we started. Now we are even thinking about 4D printing. But 4D, it is a way ahead. They started in the US, maybe in Europe, some places, and we said, no, we can't do it ourselves. We start with our kitchen, our lab. Last year, I had my PhD. He worked on a smart material, and a material which can be used in structure for self-repair. For example, the PhD student, he's working on the bridges, and he thought that if anything happened to the bridge, it will be difficult to repair again. Time consuming, effort. Why we don't make it smart bridge? And he finished his PhD on smart material. And we were successful in making some part of the bridge for a self-healing. Now, why I'm saying 4D printing? We are still in the 3D printing technology. We didn't master it until now, but we are on the process. But there's something come up now, 4D in the world. Why we don't go through it? Maybe we can get ahead of the manufacturer in our lab. We have to get experience on that one. And that is the smart material. The 3D, the 4D, it is one step additional to the 3D. 4D, it is something, the structure or materials, it can change behavior with time. So the other parameter is the time function. In time function, for example, in the Emirates, we have the weather is different from winter to summer. This, it may entail some behavior for the building. Maybe we are talking ahead of thinking, natural thinking, or ordinary thinking. But this is coming. This is coming. They are adding the fourth dimension to 3D. For example, I give you example. What they found in some advanced state that they are now manufacturing tubes for drainage system, and these pipes or tubes, it can expand or contract with time. It depends on the pressure. It depends on the water flow. Why we don't do this, for example, for the temperature, for thermal insulation? So this is something one step ahead, but still, it is still in the R&D, and that's why we are in the academic. We have to go through R&D, get to be ahead of the business, and then the business is up to them if they would like to take our stuff or to test it. We are thinking about smart materials to behave differently with time. We are trying to add the time dimension. Yes, we are in the 3D concrete. We built a 3D villa, traditional villa in Sharjah. We are still working on that. There's a lot of challenges. Still, we have a lot of challenges. For example, what would be the long-term life for these 3D concretes? How long it can survive? We are now targeting this in our research. We'd like to see this 3D concrete printing villa, how long it can stay, despite the harsh environment, something like that. So we have ongoing program now in our lab to work about surface life, long surface life. Another dimension in the 3D is about the safety. What are the elements of safety with the 3D? Again, we have another one study now with master study going on the safety, which are related to 3D. So we are having the idea. We're trying to convert these ideas in kind of a practical way. And we are inviting companies, in fact, to be with us. Because all things that comes from the lab, all innovation, all technologies comes from the lab. And especially if it comes from independent lab. We at the American University of Sharjah, we are independent. We are not biased. So the government, they take our reading, they take our recommendation into practice. So we are inviting people, and we are blessed to be very close to this park. We are working with them in a close relationship, and we are inviting all of you, if anybody has interest or idea or believe in our technology or believe in our research, get in touch with us, and we can work together with our guests and with all of you. So we have a lot of ideas we try to convert them into real products. Maybe we are working ahead of time, but it will come time where people, they would like to see these ideas. So some of the ideas are in the past, we are still working with them. Some of them in the present, we are trying to motivate them, we'll try to moderate them or make them more scientific evidence. And we are working with the future. So we have our footstep in the past and our body in the present, and our thinking and our hand in the future. Of course, we cannot do all of these things in one go, so we need to work together, but we are trying our best. We have a lot of publications. Recently, for example, we publish international articles, how to make the surfaces of buildings antivirus for COVID. So there are some things which it can be achieved. So we publish this record, and we are working with 3D, we are working with smart materials, we are working with nano materials, we are working with self-cleaning concrete, a lot of things in our labs. And again, we are very happy that the research park is close to us. We can work together all the time to support each other. Thank you very much.
Thank you very much. My next question is to Mr. Fahmy. Right now, I'd like to focus on the workforce and basically, what do you look for when you are hiring your team? I'm sure coming from Imensa and as the CEO, apart from having the most advanced equipments, you also require to have very strong team, very knowledgeable in design and 3D printing. What challenges do you face when you are interviewing and basically looking to hire new staff? Are you looking for people with long experience in a new industry, which is 3D printing? And I'm sure it's very challenging to find people with that kind of experience, whom you can afford, of course. Or do you prefer to pick, let's say, fresh graduates and basically put them under extensive training and get them to understand the technology and get familiar with the machines, so basically they can grow from there? Another question is, after listening to Dr. Adil's feedback, what advice do you give to educators, especially universities teaching engineering and design? How can they prepare students better to enter the workforce, not necessarily knowing how to basically design or use the most advanced equipments, but how do you prepare their problem-solving skills and basically their self-learning ability to basically enter the workforce without basically having any issues?
A lot to digest. The first thing I want to say in terms of the workforce, I'm double the age of everyone that works at the Mensa. So it just tells you about the change in mind shift. Most of the people that work for us are actually young, fresh graduates. We haven't been very successful hiring people with 10 and 15 years of experience. And the biggest challenge has been the mind shift. Where with 10 and 15 years of experience, you're set in your ways, you're set in certain, and actually changing that mind shift is a challenge. If you're used to machining or casting, and that's the way you think about material, coming and going back to the basics, and what the term I heard recently was not re-educating, but unlearning what you learned. And it's the biggest challenge. It's tough for us to unlearn. So in terms of workforce, I think young graduates are the best sort of resource. First thing, they energize you. Second thing, they come with open minds. Technical skills can always be taught. And you get a lot of students, and to be honest, we hire a lot from the UAE. We have some fantastic caliber engineers that come here with the basic technical skills, and then you expose them to the business side of it. The second question you were asking in terms of the advice you'd give the academia, to experiment more. I love what Dr. Adil was saying. I think one of the, my generation, and I'm 45, was when we studied in school and then university, we were put on these curriculum. I studied in a British system where we, and Tawjihi, most of our academic systems was, this is what you have to learn. This is, and we didn't have to understand why. We had to learn the equation, we had to understand the forces, but nobody ever explained to us. We never really had to understand why the equation was like this, why was the calculus derived this way. I think experimentation is more important than technical skills. I think technical skills will keep evolving, technology changes. The principal of my daughter's school taught me something recently which was fascinating. He said, education is shifting. We don't teach the children the skills anymore. What our job is to teach them how to educate themselves. Because whatever they study in university today, likelihood of it being obsolete in 4 to 6 years is quite high. Whether you're a doctor, whether you're a mechanical engineer, whether you're an architect, the technology you use is going to be obsolete. The methods you use are going to be outdated. So the most important thing is allow them to learn how to continuously educate themselves, which means experimentation. And I love the point. Experimentation is the key. Allow them to grow and expand their mind.
So, do you want to comment?
I'll start from my first question. That was, what do we look at when we hire? First thing first. The most important thing is that 3D printing, when you're in service business, especially in the service business, the most interesting thing is that every single project that you receive is different from the rest. So there's no any, like sometimes a mom calls us and says, my daughter's Barbie doll arm is broken, can you replicate it? Sometimes it's like a defense industry calls you and tells you that we need to put specific cameras on a route, on drones, and we need a casing for it. So it varies, and usually what my team is, we are a team of 24, and most of them are fresh graduates, just like Mr. Fahmy said. And what we get out of it is because they are fresh, they're open to new ideas, they have to experiment, they're ready to experiment. People from industries that if you have, they are helpful for sales and marketing, but when technology comes, fresh graduates are more easily, because they don't get that kind of service, let's say 3D printing service experience that you wouldn't find in the market. And as a company, as a Product 21, like we have our own ways to reach out to producing things. Let's say we don't do 3D scanning at all. We have a process of photogrammetry. Now you have to develop that system. So I cannot have anybody in the market that would come from that background because it's something new I'm developing. We use photogrammetry to scan the horse of a horseback to produce a saddle, for instance. So fresh graduates at that part are more better for us in terms. The second question is what students should learn to get into this industry and learn how to do problem solving and all that part. Well, it's a general assumption that academics that we have is not, when people graduate from their academics, they don't get where they want to be. It's difficult for them, companies to hire. They keep on asking them, do you have experience enough and stuff like that. Usually, the reason why how I choose a fresh graduate, I'd never ask them what degree they have. I never ask what they studied. I just ask them what you know about and what's your attitude towards it. There's something called ethos, and that is developed in a university, in the environment, where you have like a mentality to improve. What you have known is not always right. So that kind of mentality is important, and that comes from experimentation, like Mr. Fahmy said. It comes from R&D. An engineer should spend more time in a lab than a classroom, straightforward. The more hands-on experience, the more better engineer he is, the more he will go farther. Me personally always had issues with my professors of not having enough attendance in classrooms. And I used to spend most of my time in labs, and I had a lab in my home. So that is something I see in people lacking. So when a person came and I say, what's your final year project? That answers everything what he's about. And if he's talking about theoretical, it doesn't work. If you're talking about something physical you made a drone, you made a robot, you made circuits and stuff like that, that guy would be able to find the troubleshooting in the machine when it goes down. So that's very important to be practical side strengthful than the theoretical side. All the theory is 100% very important, but then we can always look at the practical engineers that have hands-on experience are more they go farther than the others.
I'm just going to ask you the question.
Sure. Sure. Honestly, I look at attitude. It's the most important thing, characteristic you want to have in a team member. If you have a right attitude, you can always teach skills to anybody. But you can never teach character. You can never teach attitude that comes within from a past experience. Where have you grown? What university culture you have? That is really important. Like, I just look at that in choosing my suppliers, in choosing my clients, in choosing my team members. If you have right attitude, you will learn anything that is out there. A human mind is really powerful to just grasp any new skill that is out there. But with the right attitude is very important. So most probably is a passion, of course. Like if he's passionate about what he does, and this all comes under one umbrella of attitude, I believe.
Sorry? Yes, I'm going to move to you. I mean, of course, I would like Dr. Adel to comment on the feedback from the 3D printing industry, but I also want you to answer this question for me. How can you drill in the problem-solving mentality and attitude into a student's head? Because I'm sure this is something you will always face with especially employees. They are faced with a problem and their first reaction is, this is impossible, it's not going to work, which is the wrong attitude when you're working in engineering, product development, and prototyping. How do you train students to not see the problem, but see the solutions?
Thank you. That's a great question. And I'm trying just to address our guests here, what they said about critical thinking and problem solving. So how our student can jump to the solution, they cannot jump directly to the solution. Usually we engage them with a lot of projects. And these projects, they have like open-ended problems, solution. So they come out with different solution. And then they optimize which solution is good for them. Today or tonight, we were having meeting with some of our alumni, our students. Some of them now CEO in some companies, some of them in the government, one of them with Dubai Holding, CEO, and the other one in a company, CEO, three of them. And they said, what we learned in the university is how to solve problems. You force us to get to solve the problems, especially in the projects. So we have a lot of projects. We try to get them kind of critical thinking, how they come out with solution. Because if they know the technique of how to solve the question or the problems nowadays, in the future, they will, as you said, they will find different problems, different setup, different technology. So we cannot cover everything, of course, in our education. We give them just a principle, how to solve problems, how to think in a critical way, and most on that, it is the communication skill. Our students, they are better communicator than me. So they learn communication skill. They engage in kind of extra curriculum, a lot of extra curriculum. For example, they engage in clubs, in speech, in conferences, networking, all of this beside the courses. Networking and communication skill, beside how they tackle the problems, how to come out with a strategy to solve the problems. We cannot teach them everything, of course, so difficult. But at least they have the background how to solve the problems. And this is what they said tonight. They said, that was excellent things for us. I'm sure not only our university, but other universities do the same thing. So kind of solve the problems. They come out with, we give them projects, and we tell them, okay, solve these projects. We give them just basic tool, and then they come out with different solution. Then they get together and find out which solution is the best for them. Is it the time? Is it the quality? Is it money, for example? This kind of quality of the products. So they came out with different answers. So that is what we do now, exactly. We cannot cover everything, but we give them the basic thinking.
Thank you very much. I would like to move to the opportunities that 3D printing can offer to industry, especially the small and medium companies. From your perspective, when you walk into any kind of companies or let's say any kind of industry in any field, I'm sure you will notice some areas of their, let's say, production line that you can totally automate it or automate it, and use 3D printing technology to improve, let's say, their quality of products, their speed, reduce the cost, or use less labor on it. The question is, how do you convince the decision makers of these organizations that, you know what, you should try 3D printing in these parts? And how do you see the future of these companies using these technologies? If 3D printing technology is not yet ready to provide cheap and quick solutions for these companies, what is the next breakthrough in 3D printing that will transform everything we see? Do you want to start?
I think the biggest challenge is awareness, is education and awareness. The more companies that set up like Proto, like Imensa, like the rest, actually helps get people on board. In terms of small, medium-sized companies, the biggest advantage, or why they look into it, is we're not an industrialized nation. We don't have massive volumes. We don't have 100 million people. So 3D printing allows mass customization. Quantity is not, we're not restricted with quantity, and we're not restricted with limitations of manufacturability. I think there's a massive opportunity for additive manufacturing to play a role in our economies, more so than playing a role in places like China or Southeast Asia or Latin America, just because of the agility of the technology. I can use the same base to manufacture for different sectors, different components, without having to invest tens of millions of dollars. How do you get people to adopt it? I think it's awareness. It's just continuously, it's a long journey. The business development cycle with us is usually a year and a half. We slowly try to build awareness with them, try to educate them and do a proof of concept on the technology, get them comfortable with prototyping, then get them one step ahead into replicas, then go into enhanced product. And I think with more institutions coming on board, with more government-related enterprises promoting it, with more innovation parks coming, we see breakthroughs. If you want to compare where we are today in 2020, May 2021, compared to where we were in January 2020, I think the penetration rate and adoption is at least 200% to 300% increase. Globally, additive manufacturing is growing at around 25-30%. I believe in the Gulf, we're going to see the growth rate north of 150% a year over the next 3-4 years. We're starting from a very low base. And it's just a matter of confidence and trust.
In terms of the second question, what do you think that the next breakthrough that will open them up even bigger?
From machinery and technology, I don't think there's massive breakthrough. I think there's a lot of hype, but the technology, and Ismail, you know more than anyone else, the technology has been the same for the last 30 years. It's extrusion, it's very unsmart, unintelligent technology. I think the biggest breakthroughs are in material science. This is really what's going to really propel this technology. On the plastic, it's quite advanced. On the metal, it's still a bit less. I think globally, the technology globally has gone mainstream. So I always use the example, if you have gotten on any Boeing flight in the last 2-3 years, there's a mechanical component that was 3D printed and we're not aware of it. So it has gone mainstream. It's more about more awareness about where it's being applied. Caterpillar has been using 3D printing for the last 11 years, BMW for the last 6 years. So I think the biggest breakthrough is material science. That's my humble opinion.
So can you repeat the first question? Yeah. Okay. Sure. Right. So usually, again, I always give examples to explain things. So Nestle, they just called us and they got connected with us, and we visited their factory, and they said how we can integrate some of the 3D printing services that you have in your in our services. So why don't you give a tour? Because when one of my marketing lady reached them out and they talked to them. So the question itself answers, and that says, how do you convince? The thing is, this is a beautiful solution out there, 3D printing, for a lot of solutions and any companies that they can have. So when you say convince, that answers that people are not aware of them. When they're engineers, they're just, again, experienced people. You need to be a 3D printing evangelist to explain that how and why this 3D printing would help them in their solutions, in their processes, in a lot of different ways, such as one industry, if I can say, is car industry, like automotive industry here. So a lot of locals here would like to revive their old cars and make them new, and they want to like upgrade their interiors and stuff. And the only thing they find out is 3D printing there, because it's easy for them to understand that, okay, traditional manufacturing is not helpful here, it's expensive. What's the fastest way to go through? But that's not the case when the corporates come. So it's for the B2C, people know, okay, every answer to my question is a 3D printing. But the corporates, they have a setup suppliers for traditional manufacturing going on for years. For them to grasp a new technology is not just easy. So awareness programs, like we need 3D printing courses out there. They're like, if I may say, how many master's or bachelor's degrees are based on this manufacturing? I couldn't find when I finished my bachelor's. So I ended up doing master's in mechatronics. Again, it's really, if I can say, a very broad field. So how many universities are offering 3D printing degrees, for instance? Let's say not 3D printing, advanced manufacturing degrees. Very less. So those programs, if those engineers will graduate and join those big corporate companies, so it's going to take some time. And it's an evolution process. So just like Imansa was one of the first companies in Middle East, I came to Dubai to visit in 2015, and I couldn't find any other 3D printer, and it just brought me up that I want to have my own 3D printing company. So one important factor is awareness, that people are not aware, and you have to convince them for this. The who's are aware, they just reach you out and it works it out. The second question was? Right. Improve further. So I may say there are mushrooms out there that grow faster than a 3D printer can print a mushroom. This is like a kind of stereotype that 3D printing is the fastest process. No, it's not. How long is it taking this guy to print that thing when he's doing printing? Correct. 3D printing is slow at the moment, although there are like crazy new technology coming against carbon that prints in seconds. Adidas has given a big chunk they did a prototypes with us, of course, locally, but then they went for carbon technology to print mass manufacturing. 3D printing cannot mass manufacture. It's a low volume production at the moment. It cannot produce 1,000 pieces at a cheaper rate. Of course, it's expensive. A lot of challenges in 3D printing. It's evolving, although. Now we see 3D printers everywhere we go, like in schools. We see it in people, they have them in their homes. DIY kits are available on Amazon for as cheap as 600 dirhams. That's something nice. So more printers are in the market, more people are aware of it. And then the last thing that is most important is materials. That needs a lot of work. Because once materials reach out to, if we say, like in industrial materials, we have, in plastic polymers, if I may say that I'm expert in, we have PA12, and we have some really less companies. And if you say from 100 companies in 100%, there's only maximum of 20% of the companies that are doing industrial polymers. Rest of them will just melt at 80 degrees. So material is important.
All right, before we close the event tonight, let's take it a step further and talk about how the government can support basically this transition into the new basically advancement in industry. Whether through regulation, whether it's through introducing, through the Ministry of Economy, the Ministry of Education, Ministry of Labor. What kind of initiative do you think they should follow to basically improve this process?
I'm glad my colleague, he mentioned about the materials is the heart of all innovation and success. Now back to your question, I'm glad that UAE, they have regulation on 3D. They started on this maybe a few years back. They wanted UAE, or at least Dubai, to have quarter of their building or their industry. They said building in 2030 to be quarter of them built by 3D. So they are encouraging. And UAE government as well, they are adopting the sustainable goal for the United Nations. So working on these goals, sustainable goals. So adopting them, and they find mechanism to apply them. So they are encouraging the industry, encouraging the education to go through these routes. Now, even now, they enforce us. This is the UAE Ministry, Higher Education. They said, you have to have a course on leadership for all your students. So to work on, to have some kind of mindset on business and new innovation. So now we have a course on new innovation, for example. That is implemented by force by the government. Now every student has to take this innovation course, innovation and leadership. That will be starting next fall. So the government, they are making their homework for this. So now the step is on us and our colleague. I'm glad that our colleague, they get to the high tech of the technology, and I'm sure that many other people, they have following suit, and especially with the research park, we can do a lot of effort.
Thank you very much. I mean, with this, I would like to end our Tech Tuesday session for this month. Thank you very much for coming and attending. Thanks for our guests. Thank you very much. And I will see you if you would like to have a word at the end. That's it. Okay. Thank you and have a good evening. Thank you.